A large language model, LLM, is a type of artificial intelligence designed to process and generate human-like text. It is trained on vast amounts of text data from books, websites, and other sources to learn patterns, grammar, context, and meaning in language. They work using a neural network architecture, often based on transformers, which allow them to handle large-scale data and maintain context over long passages of text, which enables them to recognize, summarize, classification, translate, predicting, and text generation. A transformer model is the most common architecture of a large language model. It consists of an encoder and a decoder. A transformer model processes data by tokenizing the input, then simultaneously conducting mathematical equations to discover relationships between tokens. This enables the computer to see the patterns a human would see were it given the same query. Transformer models work with self-attention mechanisms, which enables the model to learn more quickly than traditional models, like long short-term memory models. Self-attention is what enables the transformer model to consider different parts of the sequence, or the entire context of a sentence, to generate predictions. Transformer models make LLMs to process natural language to communicate with the machine simpler and easier. Helps in computer vision, making breathtaking AI-generated photos by only using text input and making time series forecast, enabling forecasting stocks and weather much easier. Large language models, LLMs, face several limitations and challenges despite their impressive capabilities. One key limitation is their dependency on the data they are trained on. They often struggle with tasks requiring deep reasoning, domain-specific expertise, or understanding nuanced contexts, as they lack true comprehension and rely on probabilistic patterns. LLMs can generate plausible-sounding but factually incorrect or nonsensical outputs, which poses risks in critical applications. Additionally, they are computationally intensive, requiring significant resources for training and deployment, which can limit accessibility. Ethical concerns also arise, including the potential for misuse in spreading misinformation, violating privacy, or amplifying harmful content. Addressing these challenges is essential to harness LLMs' potential responsibly and effectively. One of the most notable limitations of LLM is hallucination. A hallucination is when a LLM produces an output that is false or that does not match the user's intent. For example, claiming that it is human, that it has emotions, or that it is in love with the user. Because large language models predict the next syntactically correct word or phrase, they can't wholly interpret human meaning. The result can sometimes be what is referred to as a hallucination. There are 3 ways to optimize and resolve hallucination: fine-tuning, prompt engineering, and retrieval augmented generation. What are prompts? In order for a large language model to perform a specific task, such as translation, it must be fine-tuned to that particular activity. Fine-tuning optimizes the performance of specific tasks. Prompt engineering is a technical term for a straightforward action. It means prompting or requesting a generative AI tool to perform a task. Prompt tuning fulfills a similar function to fine-tuning, whereby it trains a model to perform a specific task through few-shot prompting or zero-shot prompting. A prompt is an instruction given to an LLM the language model would understand, through the semantic meaning of hideous, and because an opposite example was provided, that the customer sentiment in the second example is negative. Alternatively, zero-shot prompting does not use examples to teach the language model how to respond to inputs. Instead, it formulates the question as, the sentiment in this plant is so hideous is. It clearly indicates which task the language model should perform, but does not provide problem-solving examples. What is fine-tuning? Fine-tuning is a process used to adapt a pre-trained large language model, LLM, to perform specific tasks or cater to domain-specific needs. This involves training the model further on a smaller, specialized dataset, allowing it to learn task-specific patterns, terminologies, or contextual nuances without requiring extensive retraining from scratch. Fine-tuning can enhance the model's performance in applications like customer support, medical diagnosis, legal documentation, or creative writing. However, fine-tuning requires careful curation of high-quality, balanced datasets to avoid introducing new biases or overfitting. It is also computationally demanding and requires expertise to optimize hyperparameters and manage the trade-off between retaining general knowledge and adapting to specific needs. Despite these challenges, fine-tuning is a powerful technique for customizing LLMs, making them more precise and efficient for targeted applications. And the last optimization is RAG. Retrieval Augmented Generation, RAG, is a technique that combines pre-trained language models with external information retrieval systems to improve the accuracy and relevance of generated responses. Instead of relying solely on the knowledge encoded within the model's parameters, RAG dynamically retrieves relevant documents or pieces of information from an external database or knowledge base during inference. This retrieved information is then used to guide or augment the generation process, allowing the model to provide more accurate, context-aware, and up-to-date responses. RAG addresses some key limitations of LLMs, such as outdated knowledge or hallucination of facts, by grounding responses in verifiable external data. It is particularly useful in domains requiring factual precision, such as legal, medical, or technical applications. However, challenges remain, including designing effective retrieval systems, ensuring the reliability of the external sources, and seamlessly integrating retrieval outputs with generation models. When implemented effectively, RAG significantly enhances the utility of language models in knowledge-intensive tasks. LLMs are incredibly versatile and have many practical uses in everyday scenarios. Chatbots. They power smart chatbots that can answer questions, solve problems, or even just have a friendly conversation, making customer service faster and more efficient. Text generation. From creating marketing content and blog posts to writing stories or reports, LLMs can help generate polished and creative text quickly. Language translation. Breaking language barriers, they offer accurate translations while keeping the original context intact, which is great for businesses and travelers alike. Sentiment analysis. Businesses use LLMs to understand customer opinions by analyzing reviews, social media posts, or surveys to improve their services or products. Question answering. Whether for personal use or in professional settings, LLMs excel at answering queries, summarizing information, or helping with research tasks. Code generation. Developers can save time by letting LLMs write code snippets, suggest solutions, or even debug programs, making programming more efficient. These applications make LLMs valuable tools in enhancing productivity, improving communication, and simplifying complex tasks. That's it for LLMs. If you liked the video, please don't forget to like and subscribe.